Hey everyone, and welcome to today's Explainer. We're going to be looking at an absolute masterclass in micro-refactorings. We're digging into the Notes-on-Haskell-Programming series, specifically Part 188, which was published by Ang back in July of 2026. Now, this entry might seem kind of small at first glance, but it actually tackles one of the most persistent challenges we face in functional programming: how we visually parse our own code.
So, think about this for a second. Can changing a single character fundamentally improve how you read code? In programming, we usually think of refactoring as these massive architecture-altering events, right? We're moving directories, we're decoupling modules, rewriting entire classes, the whole shebang. But what if a single keystroke swap could completely shift your mental model of a function? Well, that is exactly the premise Ang puts to the test.
All right, Section 1, Refactoring for Better Readability. Let's just dive right into it.
Haskell is a super elegant language, for sure, but man, it can turn into a dense forest of symbols if we aren't careful. And that's really the driving force here. Ang explicitly states that the whole goal is, quote, improving the readability of my Haskell code. This is a relentless pursuit of clean code. We're not talking about making the compiler faster or the binary smaller. It is entirely about reducing the cognitive load on the actual human being sitting in front of the monitor.
Moving on to Section 2, the limit of simple replacements.
So to get this readability boost, Ang brings in a tool called the flow library. Now, introducing a new tool sometimes starts with a whimper rather than a bang. Just looking at this simple import statement, adding this new operator, which is the less than sign followed by a pipe, it doesn't really show much of an improvement on its own. It's just a simple replacement. Honestly, if you're doing a one-off swap in a massive file, your eyes would probably just glaze right over it.
Which brings us to Section 3, Visualizing the Data Pipeline. This is where things get really interesting.
We've got to think about the physical shape of the syntax itself, because our brains process physical shapes way faster than abstract concepts. Notice the direct contrast between the traditional $ operator and the flow library's operator. In Haskell, that $ is incredibly common. It's used all the time for function application just to keep us from drowning in parentheses. But visually, it's just an abstract squiggle. It doesn't tell your eye where to go. But look at the flow operator. It literally looks like an arrowhead. It is directional. It implies movement. And that is exactly why Ang notes that this swap will clearly improve the comprehension of the code by suggesting the direction of the data pipeline. Think about how powerful that actually is. Instead of your brain having to pause, remember what the $ does, and logically deduce the flow of data, the symbol itself literally points the way. The data is flowing into the function. The visual cue perfectly matches the logical action.
Okay, let's look at Section 4, the ultimate code makeover.
It's time to actually put this theory to the test on a denser block of code. Imagine the before state for a function called validate args. Right off the bat, it's cluttered. You've got a run except t followed by a $, then a lift io $, then an unless exists $. It is the standard way to write this in Haskell, but visually it's just a wall of disconnected symbols. Your eye basically stops at every single jagged edge.
Which leads us to the million-dollar question. Does a simple replacement actually help here? Like, is swapping out a few characters really going to fix a dense block of monadic code? Or are we basically just rearranging deck chairs? Well, let's see what happens.
The transformation is honestly brilliant. When you compare the static $ from before against the new flow operators, it's night and day. Run except t, arrow, lift io, arrow, unless exists, arrow. Suddenly, you aren't just reading flat text. You're following a map. Those new operators visually guide your eyes seamlessly right through the nested data flow of that validate args function. It genuinely feels like a pipeline. All that cognitive friction is just gone.
It's a fantastic micro-refactoring from Ang's notes, and it proves that great code isn't just about logic, it's about typography and visual flow. Which leaves us with a final thought to ponder today. If a single symbol changes how you see a data pipeline, what else in your code needs a new direction? Take a hard look at your own syntax habits this week. Thanks so much for joining me on this explainer, and keep learning.